direction. Now we're back to not really being sure which direction it came from after all. If we go back in time, what we would see is a pinpoint of light coming at us. As it came closer, it would have gone very bright. I'm sure it would have been beautiful. We never would have lived to tell about it because we sat inside with that tremendous force, making our crater in just 10 seconds. When it hit, the back part broke off, scattering pieces like what we have on display in the Discovery Center. What was left in the crater just obliterated. Some vaporized, some melted, some smashed into small little pieces. Really not much left there in the crater in one piece. Before that, though, it was at 150 feet or 45 meters we mentioned. You get a better look at the lower parking lot here, half the size of that lower parking lot. Now the crater that it made, 2¼ miles around, 4,000 feet across, but 1.2 kilometers across, and currently 550 feet deep. Well, the Native Americans knew that it was here, but we didn't have a written history until 1871, when an Army scout named Franklin marked it in his records. Even then, people weren't thinking much about it. In fact, the first serious scientific research wasn't until 1891, when the chief U.S. geologist named Gilbert came by. He thought it could be an impact strike, so he wanted to see it for himself. Of course, they didn't know much about strikes back then. He thought he was going to find a giant meteorite laying just below the surface. He didn't realize it was smaller to begin with and had blown to bits. So when he couldn't find the giant meteorite, he decided, this is not an impact strike, and decided instead it was something volcanic, steam, or a gaseous blowout. He's the chief U.S. geologist, so everyone accepts that idea until 1902 when Daniel Barringer comes along. He's a miner, and he thinks, like Gilbert, there's a giant meteorite lying below the surface. He just figures it's deeper than Gilbert thought it was, and that's why Gilbert never found it. So his idea is to get that meteorite out, melt it down, sell the iron, and make some money. It's a good idea. So with dreams of riches, he heads to Washington, D.C., files 4 mining claims, gets some partners, and starts mining. In fact, that's what we see right there in the center. That is where he sunk his very first shaft. The machinery over to the left, it's a steam winch and a boiler left over from the mining days. To give you another idea of the size of the crater, the long one down there kind of looks like a barbecue grill. That's the boiler. It's 15 feet long and 10 feet high. It doesn't look it, does it? The white stuff is called pulverized coconino sandstone. Coconino sandstone is a geological layer that runs under a large part in northern Arizona. That part right there was pulverized, smashed into bits because of the impact of the strike. It's so fine, people call it rock flour. No luck drilling there. He tried other places. Those are the other holes you see along the bottom and the side. He kept on drilling until 1929. That was the year that Daniel Barringer passed away. Never found the giant meteorite because we know today it just blew into bits. But along the way, he was writing down certain finds that he thought helped prove this is an impact site. So years after his death, when he was finally proven right, they decided to call it Barringer Crater in his honor because of the significant discoveries he made way back in the mining days. Well, passed on to his family. They used to own it today. They wanted to preserve it. So eventually they joined with the Bar Ranch, that's the ranch who drove across to get here. And in 1942, they opened the very first museum. And then that agreement eventually grew into Meteor Crater Enterprises Incorporated that operates what we have here now. But even with all of that going on, there's still people saying, this is not an impact strike. It wasn't until the late 50s and early 60s, Eugene Shoemaker came, that it was proven to be an impact site. Ours became the first proven on the planet. And then in 1968, it became the national natural landmark that it is today, which means it's held in trust and protected as that impact site. Now, Dr. Shoemaker was a geologist, but he wanted to be an astronaut. He wanted to be the very first geologist on the moon. And this was during the age of the Apollo programs. When I was 8, I wanted to be an astronaut. Anyone here ever wanted to be or no wants to be an astronaut? No, is that at least one? Well, Dr. Shoemaker wanted to be one. He said the best thing to do is become an expert on craters. So he came out to see ours. Now, before that, he was sitting in nuclear test sites, especially the underground explosions, and ours was basically underground too. He found this site had a lot in common with the nuclear sites been studying. The most important thing was something called shocked quartz, minerals that can only be created under extreme pressure. Such extreme pressure, only 3 ways that we know of here on Earth. 1, a nuclear explosion. 2nd, in a laboratory. And 3rd, impact strike, just like ours. Since that discovery of shocked quartz proving this was an impact site, they have found nearly 200 other impact sites all throughout the world. In fact, in our Discovery Center, we have a display with a map showing you where some of those are. Well, Dr. Shoemaker never became an astronaut because of health problems, but he did convince NASA to come here to learn about crater geology, because he knew when they went to the moon, they wanted to get rocks from many different layers, not just the surface. That bringing drilling equipment would have been difficult. So Dr. Shoemaker saw something on our crater he knew would be helpful, something you can see on all impact craters, and that's an inverted strata. When the meteorite hit, it went through several geological layers, but then it still had that energy left obliterating the meteorite and threw material out. So everything on the bottom was thrown out and thrown on top, as the Earth just basically turned over on itself. Well, we can see this inverted strata very clearly here on our crater. So let's talk about the geology here for a moment. 50,000 years ago, when our meteorite hit, it was a colder and wetter climate. There were animals here then. We had mastodons, woolly mammoths, giant sloths. In fact, if you ever saw movies about the Ice Age, some of the animals in those movies, same types of animals that were here when the meteorite hit. We don't believe there were people here then, and we're not really sure if the animals were talking back then or not. They were at the same time. Now, 50,000 years ago, it's probably more like a grassland, but just as flat as we have today, with the surface the same reddish rock we have out there now, the Moenkopi sandstone. Now let's look at our crater. Underneath here and all along the sides and the top, do you see that reddish rock? It's the same Moenkopi sandstone. The surface when the meteorite hit. You'll notice it's higher than the desert floor because everything was pushed up in the explosion. In fact, if you look over here, see how those rocks are stretched upwards? Those rocks melted, became almost as soft as taffy as they're stretched up like that. If you look underneath it, it's a beige colored rock. It's the Kaibab limestone. If you went out the desert and drilled, it'd be the next area you'd hit. And then we talked about the bright white coconut at the bottom. But now as I go along the top, do you see the lighter rocks? It's the Kaibab and Coconina rocks were thrown out part of the ejected material. In fact, these rocks up here are the Kaibab ones thrown in the crater up into the air and plopped right down where we see them today. So all of these rocks on top are older than the reddish rocks you drove across to get here. And if this hadn't happened, it'd be on a flat surface, but instead we're on that uplift and ejected material. And that's what Dr. Shoemaker taught the astronauts, how to recognize the ejected material so they could get rocks from different layers without having to drill for them. Another thing they did is they tested equipment here. One day, one of the astronauts was testing his spacesuit when he fell and the spacesuit tore. You can imagine how upset he was. If that would have happened on the moon, he never would have survived. Thank goodness it happened here first. They fixed the suits, made them more sturdy. Then, when an astronaut did stumble, it wasn't a problem. Well, NASA still does come here, along with many other scientists. Our crater's not the biggest or the oldest, but it is the best preserved crater on the planet. A couple of reasons. 150,000 years ago, geologically speaking, not very long ago. Also, we don't get much moisture here. We only get 7 inches each year. That includes both rain and snow, so we don't get a lot of water erosion. But the most important reason is probably the giant umbrella we put over it every night. If you don't believe me, I can tell. Yeah, right, we don't have an umbrella. So why study impacts? And there's a lot of reasons, but 2 main ones. One, we think our Earth was formed by impacts, so we can learn more about our planet. Second reason is, as I'm sure you've heard, it's not a matter of if, it's a matter of when something will be coming at us. The more we know about that, the better able we're going to be to protect ourselves. Let's take our crater, not the biggest. Biggest one is in South Africa, 185 miles in diameter. It's ginormous. Let's compare it to another famous one, the one down in Mexico that caused or helped to cause the dinosaurs to go extinct. Then when the crater is about 110 miles in diameter. So you can see ours is tiny by comparison at 4,000 feet across, not even a mile, but it still had an effect on the area. Remember the RV park you passed on the way in, that dome building with the gas station? There it is way out there in the distance. It looks like a little white dot from here, but that's the building. It would have been incinerated, burned up because of the fireball coming off of this impact. Anything within a 10-mile radius would have died or been seriously injured from the shock waves. And they would have felt hurricane force winds as far as 19 miles out. If you're traveling along I-40, that's by Winslow. So you can see ours didn't have a global effect, but it did have one locally. If something like this was to happen in a city, it would be devastating. So on that unhappy note, I know we had a question on the way up here about, I gave you a little information about the plane. Someone was asking about those shiny pieces down there. It's actually part of a Cessna plane. We have a 500-foot ceiling over our crater. You're not supposed to fly lower than that because it's difficult to get lift to get out again. But one day, two pilots in a Cessna broke the law and they flew right in. Once they got in, they found out, sure enough, they could not get that lift needed to get out again. They tried to land, the wheels locked, the plane flipped. They survived, but they had to be air evacuated out, got into a whole bunch of trouble.